Hi, welcome to Digital with Darren. I have a master's degree in physics at Imperial College London and graduated in 1997. I designed satellites at Matra Marconi Space, and I spent 20 years as a quantitative trader on proprietary and flow trading desks in the City of London. Right, in this section we're going to go through data types in nodejs and JavaScript, and in this video I will be looking and reviewing three different data types in Node.js or JavaScript. And the three types are here. They're the string, the number, and the boolean. There are other data types, which are the array and an object, but they are slightly different in the sense that they actually contain the previous three that are highlighted here in green. The difference between the data types is what the variable holds. So the first data type is a string. This is a string of characters. It can be A, B, C, D, as in here, or it could be hello world, how are you? And if you notice something here, I've put in a single quotation mark here and a double quotation mark here, and in JavaScript they're the same thing. And also over here we've got this little, I'm not even sure what they're called, little quotation marks. It's next to the 1 key on the keyboard, and they're also valid. They're used in a slightly different way in JavaScript, but yeah, all three formats are valid. An example of defining a string in Node.js or JavaScript with its full syntax is as follows. We type in var and then myString, and then you put in the string value surrounded by the quotation marks. And then at the end of it, you ought to put in the semicolon that would represent the end of the line. In shorthand, we do it like this, which is we could just do m instead of myString, and then assigns the value of, with equals means assigns the value of, and then my name is Darren. We can use single quotation marks. We could do both of those formats, and let's just go through that. So we could do var myString. My name is Darren. So that's the first way of doing it in Node.js. But also we could just have equal if done, and it's a shorter format for doing it. But m equals single quotation marks. My name is Darren. Both of these work, and we could log them to the console. So we just type in log and console into log console. So the first one would be myString like that. And the second version would be, well, I'll actually just run it in the console and we'll just see. So I'll hit F5 here. We go to the console and we see over here it just says my name is Darren. Get rid of the console. And also we can just go here and just do the same, exactly the same thing. So instead of having myString, we will have a M, just like that. And it's going to do the same thing. It's going to take m and log it to the console. My name is Darren. So let's just hit F5 and watch it run. And there we go. It says my name is Darren. So we're going to look at concatenation now, and concatenation basically is the joining up of strings. It's literally as simple as that. It just means adding strings, joining strings, concatenating. So in order to join two strings, we need two strings. So our first string was an M, and we'll just set our second string to be an N, and we'll just give it something logical. So we started with my name is Darren, and we might just have and I am happy. And what we'll do over here is we're going to create a third string that's going to sum up the first two strings. So we'll make another variable s, and we're going to set it equal to m for my name is Darren plus n and I am happy. And we are going to log this to the console, but just want to notice one thing before we do that, which is when we have done this summation, JavaScript doesn't know to put a space between the strings, and I haven't put a space here. And what's going to happen is, well, we'll see when it actually runs. I'll hit the F5 button and that will run it, and we're just going to see what happens. But what we do get is we got the Darren and there's no space there, there's no gap. Now there are there's actually quite a few different ways we can use a join function or other functions. But one method that we could do, for example, is just put a space here, and that would create the necessary space in order to make the string readable for a human. An alternative, and just by way of example, is we can just keep adding. So we'll just put quotation marks. Now there's no space at the moment, but when I press the space bar, there's one space in there now, and then we'll just put a plus sign, and we've now got our string s is equal to m plus a space plus n, and that should run fine. And that's just going to be an example of concatenation here. So, and here we go. We've got my name is Darren and I am happy. So that's really concatenation and joining of strings. Okay, so next on our list of things to do is numbers. We'll just scroll down here to get the number at the top. And a number, this could be an integer number, such as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100, 1,000, a million, etc. Integers can also be negative numbers. You can have -1, -100, -2 million, and so forth. And also the number 0, that counts. Or this could be a floating number. So we've got integers up here, and we've got floating numbers over here. And if we just go, what's a floating number? It's a number such as 2.5, 3.8, pi would be a floating number, although pi goes on indefinitely. I've rounded it off here, but you've got the 3.14159. And equally, all of those numbers could just as well be negative, so any like -2.5, -3.8, or even minus pi, they're all equally as valid as floating numbers are negatives. Now, when we declare a number, we declare numbers in Node in the following way, and this is like the full language for it. We do the var, and then the pi equals to 3.14159, and then we put the semicolon at the end, or we could do var myAge, and then it's 45. Or again, we're going to move straight to the short form, so we could do one or the other. We could just say pi is 3.14159, and we can say myAge is 45. So we just hop along and actually go and do that. Right here, so we go pi equals 3.14159, and we've got the myAge equals, and we just set it to the number 45. Now both of these variables are set here, and let's scroll down a little bit further. Node.js and JavaScript is loosely typed. It's a loosely typed language. What does that mean? Well, to demonstrate what this means, I guess we're going to compare it to a strongly typed language like C++ that requires every variable to be declared with its type before its first use. So, for example here, and if we look at the top, we've got the C++ version, and what we have to do is we actually have to specify int for integer. So, if our variable is a, we're actually telling the computer in this strongly typed language that our variable is of type integer, and we give it a value of 100. And likewise, if we had a number and we called it my number and it was 3.14, this is not an integer anymore, it's a floating number in this strongly typed language, and we'd have to declare it as a float. And what we could not do, so we cannot now set a equals to 100.25, because we'd get a conflict. The strongly typed language would be expecting an integer, and actually what's happening is it's getting a float. And likewise, if we wanted to set my number equal to the value 3, we would have to do it by setting it to 3.00, because the strongly typed language would need to read it as a floating point number, and it would need to see the decimals to know that it's floating. Now, conversely, we've got this loosely typed language. This is a language that we're using, which is nodejs or JavaScript, and we can just put in numbers as they are. So we can say x equals 3.14, and we can just say y equals 3. And what we have here is the x equals 3.14. We haven't had to specify that it was a float, and we never had to specify that y was an integer. We could just literally put in whatever we liked for them. So here, what we have is x is just a number with decimals, and y is just a number without decimals, but what they both are is they are just numbers. So we're going to say that it does not matter what we put into the variables. In fact, we could even change them to strings or other data types. Well, we know we'll go through another data type, but we could literally actually just set x equal to hello world after we've set it equal to the number 3.14. So we'll just go and put that in here, and we'll just see how this goes. So we go to our numbers. Oh, we've got pi in there already and myAge, so we've done that. Let's stick in x equals 3.14 and y equals 3. And these are the two different types, and we can just completely just write over them. So we can go x equals after we just say hello world. And JavaScript actually doesn't care. So JavaScript is literally going to overwrite text. And what we'll actually see is if we log this to the console like that, and then stick the x in, and we run the code, instead of getting 3.14, JavaScript so loosely typed that it just says, it just sees it as hello world. So it hasn't come up with an error or a conflict or said like, you know, this number, it's this is a string and we weren't expecting a string, we're expecting a floating point number. We had none of that. So we just have to be aware of that in JavaScript. It gives us some flexibility, but at the same time it could create problems for us. And this is our point here. This has the advantage of flexibility, but the disadvantage of errors creeping into the code where the programmer may have confused the data type. You may have put something wrong in there. And that's pretty much it. The next bit we're going to look at is actually incrementing a number. So in the example that I gave, I had the myAge, and myAge is going to change every year. So next year, if I'm 45, I will be 46 next year. And this is quite a common thing, changing of numbers. And there is a process for changing numbers. And we could just, for example, take myAge and then add on 1 and set myAge equal to myAge plus 1. So our new age is equal to our old age plus 1. And that's perfectly fine to do. But there's actually a shorthand in JavaScript, and that is to put a plus plus. It's actually in other languages too. You get it in C++. In fact, that's where the terminology for C++ came from. And yeah, we'll just stick that in and show how it runs. But so we've got the number y equals 3, and we're just going to do y plus plus, and then we're going to log to the console the value of y. And whereas before we had a 3, so y was initiated at 3, it's now going to be y plus plus when it gets down to this line, so y will turn into the value of 4, and we should log to the console the value of 4. So let's just hit F5 and run it. And here we go, we see the value of 4 that's in the console. So that's incrementing numbers. Now there's one extra point to note, which is the something called a floating point error, and this is quite an interesting one here in JavaScript, and something that not that many people might expect, especially from a simple calculation I'm going to show in this example. So here's the floating point error example. We're just going to take this, in fact I'll just put it in here. We'll just take this very simple thing here. Floating point error. And we're just going to say that x equals 0.1 plus 0.2. Now we can all pull out our calculator and we know what the value should be. The value should be 0.3. But when we do this, let's console it, log it to the console. So we'll do log and then put in the value of x. And then when we hit the F5 button to run it, we pull up this very odd answer here, which is 0.3 and loads of zeros, like 10 or 15 zeros here, and the value 4 at the end of it. So it's not exactly 3, it's slightly more than 3. We have a little bit of an issue. The calculator within the computer isn't adding up correctly, and that's a bit of a problem. And that's called the floating point error. And there is a way that we can fix it. We can bypass it with a function here called toFixed. So we're going to use this keyword function, and all that we have to do is we have to turn x into x toFixed, and then we can set the number of decimal places that we want to fix it to. So here we will do x dot to fixed and the value of 3. We can do it like that. In fact, actually, we will just reset x. We just say x equals x dot to fixed, and then we'll log that to the console log. We'll put the value of x back in there, and underneath where we had the 3.000004, we should have a correct rounded number. We'll just watch it run, and here we go. And this error, it's a bit of a nuanced error, but it does make a difference. In particular, when we look at large numbers. So I'll scroll down, I've got some examples here, but this is an annoying feature. And the examples are, if we look at, for example, the US federal deficit is in trillions. We'd multiply our number, this 3.000004, and we'd think that, oh, that little 0.0004 right at the end doesn't really make much difference. But actually, if we look at it here, if we're multiplying it by 10 trillion, for example, that's going to make quite a big difference. In fact, 10 billion, 10 trillion. The numbers get humongous when we talk about the deficit. Again, if we look at the Earth to the Moon, it's 384,000 meters. So again, if we're multiplying this floating point error, we're trying to land on the Moon. We could be out by a meter or two or half a meter. It might make that kind of difference. And again, if we look at something, for example, like we're trying to fly to Mars and we want to have some accuracy, and we've got this tiny little error and it's manifesting itself, especially if it multiplies itself, that could be quite meaningful. Now I'm just going to scroll back up because the floating point error doesn't actually go away. Although we've turned x into x fixed, if we take the x again and then we say we're going to multiply x by 3 as such, we'd expect that the new x that we had, which was 0.3 times by 3, is just going to give 0.9. So we're just going to log that to the console and see what we get out of there. And we should get 0.9, but in fact what we see that we get is 0.899999 recurring. So whereas the floating point error before hit just above where it should, on this one it's actually hit just below where it should. But in both cases it's annoying and wrong and it's incorrect. And there are ways of fixing it. Again, we just got to be aware of these when we do it. We could say, for example, just take the whole of the x dot 3 and turn it into 2 fixed, and we could fix it to, instead of 3 decimal places, maybe just want it to 2 decimal places, and we could run it like that, and this time the 0.899999 will disappear and become a regular number that we were expecting to get, which is the 0.90. And here we go, we get the 0.90 in the calculator. So we're just going to be aware of floating, or what we're going to call a floating point error. Now the third and final data type that we're going to look at is the boolean. So we're going to fill out this boolean section here, and a boolean number is one that is either true or false. A boolean number can only take one of two states, true or false. In JavaScript full syntax, we would write it as we have on this little white section here, where we've got var am I happy equals true. And in the shorthand, we could just do something like is sky red equals false. And again, we're going to go for the shorthand option. And also, just as a side note, notice that I have used a different variable writing method. So there's a few different methods, but two of the popular ones are something called snake case, where you put an underscore between the variables, and another one where you put camel case, which is where you capitalize letters, and both make the word stand out. So when I was in the example above on the previous one, where I used myAge, I actually used camel case, and in this boolean example here we're choosing to use snake case. It's just up to the user's thing, but anyway, that's not the important part. Let's go through boolean values, and the first thing we need to know is how it works. So let's just do it. I underscore am underscore happy equals, and we can set it to a value in it, and we can only be in two states. We can either be in a state of happiness or a state of unhappiness. So it's not going to be true or it's going to be false. I could stick the value of true in there, true. And we notice that it comes up in the color blue here on this particular editor. It could be a different color, but the whole point is that it is a specific type. And in particular, when we talk about booleans, it's used for something. Can it be used, for example, in the if statement? And here we'd have a condition, and the condition would be, are you happy or not? So we could put I underscore am happy. And if I am happy, then this block of code here will run. We're going to go through the if statement in another tutorial, but at this point in time, if I am happy, we might want to say something like, or log to the console, I have a smile on my face. And if we run that, F5, we'll see that the boolean, which could only be in one of the two states, true or false, and the condition is tested, and it's if I am happy, then this piece of code is going to run. And then we could set else if we're not happy, I am sad, so we could log to the console, not happy. Now when we run this code, it's still going to run because we haven't changed the status from true to false yet, so it's still going to go through the code here and just run the true status one because it still recognizes that I am happy. And when we change it to false and run the code, this time the question of the I am happy was not, it gave a false result. So this block of code between the two curly braces over here didn't run. And the next block of code, the else case happened, and we got the unhappy status. And that's pretty much it for booleans. They're actually quite simple. We could replace booleans with just ones and zeros. So instead of having true, we can have 1, and instead of having false, we could have 0. So we could actually put that in. And right here, instead of true, we could have the value 1, and again, that's going to produce the smiley face. And code's running. We have a smile on our face. We could then just set it to the number 0 and run the code again. And the ones and zeros represent true and false. But the reason we don't really use ones and zeros, and the reason we stick to booleans, is special in terms of what it means to a computer. It's a type of its own. It's the simplest of types in a way, but it literally the computer interprets ones and zeros, but humans like to know the true or falseness, and we don't want to confuse the ones and zeros with other integers, for example. So we have this type on its own, and that's the Boolean type. Okay, so we finished with our 3 different data types, and we also recognized that JavaScript was a loosely typed language, and what that meant was we might pass a string where we meant to pass a number, and that would create a problem somewhere down the line in our program. And in our little example here, we've got like n equals 20, this is a number, or n equals 20, but in quotation marks, well, this was going to be a string, and they're not the same thing, they're different. And if we were to multiply 20 as a string by the number 5, that would create an nan error. I think we've seen that in one of the previous videos. So let's just go and put this into the actual console here. We should put n equals, and we can just set any number, n equals 100. Okay, and we want to know what type this is. And in fact, let's just display this, and we can do n equals hello world. Now, when we log this to the console, let me stick n in here, we're going to get whatever the last type was. So here we've written n equals 100, and imagine we've written lots of code in here. So we've got lots of code. And we're all well and good with that. We've done loads of code. And then for some reason, we've forgotten that we were using n, or we're expecting n to be this integer value at the top here. And we wanted it to be 100. And we've reassigned it accidentally to the string that says hello world. And when we come along and we want to print this to the console, we hit F5 to run it. And what happens is we get this hello world, and we were expecting to get n equals 100. Now, even worse than that is we might have wanted to do, for example, n times by 20. So 100 times by 20, and we might have wanted to get 2000, and that's what we're hoping to. But instead, what we're going to do is we're going to have hello world times by 20, and it's not even going to have a meaning in JavaScript. It actually would have a meaning in other languages, but here it doesn't. And we get this nan value, so it creates an error. It breaks our program, and this is problematic. So on the one hand, we've got this loosely typed thing, which is nice. We can just put in any numbers and variables and overwrite them and never have a problem of kind of like having to go through and be structured with it all. But on the other hand, it can create these errors. But fortunately for us, there is a keyword that helps us, and it's a type of keyword. So we just scroll here. In Node.js or JavaScript, we can check the type using the type of keyword. And for example, we can set x equals 10, and this would be a number. And then in order to get the type of x, we could set another variable, which is x type. We could name it anything we like, and then we could make it equal to the value of type of x, this function. So let's actually go through it so we can see how it really works. So here we've got n, and we might just have like n type equals, and we're going to use this type of function, type of, and we're going to take value of n. Now we're just going to cancel out the console.log for now, but what we actually have is we have n type is type of n, and if we log that to the console, we should get what the type of n is. And now here initially we've got n, and it's a string because we started up here and it was an integer, but it's been overwritten on line number 73. It goes into here, and it looks at it and it says, what is it? And n is hello world, is a string, so n type is a string, and it should come out in the console. Let's run it. And here we go. At the bottom here, underneath the not happy bits, we've got a string. And if we were to remove this hello world here and rerun the code, so we didn't make the error, and n was actually set to the 100 right at the top here. So the type of n was a number. It's not, remember, although it's an integer, it's actually just a number to JavaScript. So we hit the F5 key and run it again. And this time we get number. So there is a checking method. This type of provides a checking method. So let's go along and do it. So we can do a check now. We can correct our code or make sure our code comes in the right format. So we can have a checking method. And we might use, again, we're going to go through if statements and other types of functions and statements, but if is a very popular one. So we'll do this if statement. If n type is equal to a string. So if it's a string, we don't want to run the code. Log. This is an error. We don't want to run the code. And we might actually change it. N will change it to a number. N equals, we might change it back to the original number that it was, 100. In fact, let's change it to a different number, 200. This is an error. N is changed. Now, if we did have a string and it came in and hit it, then we would bypass it with this if statement. So let's just have a look at this. And when we come down here, we've got the n type, but let's also log to the console actually the value of n, and we'll see what we get here. And we're going to hit F5, and we get a number and we get 100. Now of course we get a number and we get 100 because n is set to 100 and it comes down and it doesn't hit this. This isn't uncommented at this point in time, so the type of n is still a number. It's not a string, so this if statement doesn't get interacted, and it comes through and we get the number 100. Now if we remove the commenting from here by pressing the control and / which is a shortcut key on Visual Studio Code, and then we hit the F5 button again to run it through, the type of n here, we see the value has changed now to 200, and the reason why is n was 100 here, but then n became a string. It became the hello world string, and the type was therefore a string, and if type equals string, we've got an error, and here it is. This is an error. We've caught the error, and on catching the error we change n back into a number, but we changed it into a number that was different to the original number. The original number was 100, and that's just to differentiate between the two. And we can see that our type is a string, but then we changed our type to a number. So we had type there and it was string, and we've changed it to a number, and now we've got the number of the value 200. And that pretty much is a summary for types of variables. So thank you for watching my video. I hope it was helpful. And if you did like it, then please press the thumbs up like button and also press the follow button below. I will have more programming videos and also some trading and math ones to come too. Thank you very much.